Welcome to Dark Sky Dive. Today, we explore the monumental engineering challenges required to transport humans safely to the Red Planet. Mars calls to us across the void, a rusty beacon in the night sky, promising a new future for humanity's expansion. Leaving our home planet is not merely a dream, but a necessity for the long-term survival and evolution of our species. However, the journey is fraught with peril, requiring us to solve a complex chain of problems before we even leave the ground. This is not just about building a big rocket, it is about mastering the logistics of space travel on a massive scale. Every calculation must be precise, for a single error in the trajectory could result in the crew drifting forever in darkness. The destination itself is hostile, with a thin atmosphere that makes landing heavy spacecraft one of the hardest challenges in physics. Beyond the hardware, we must consider the fragile human body, which is vulnerable to deep space radiation and psychological isolation. Imagine being millions of miles from home, where a simple message takes 20 minutes to reach the people you love most. Join us as we dissect this mission step by step, analyzing the roadmap and the life-or-death barriers we must overcome. The first major hurdle is the ever-changing distance between our two worlds, which is dictated by the laws of orbital mechanics. At their farthest, Earth and Mars are separated by over 400 million kilometers, making travel practically impossible for current technology. We must wait for the planets to align, a celestial synchronization that only happens once every 26 months, called the transfer window. This strict time limit means if we miss the launch window, the mission is delayed for over 2 years of waiting. Engineers utilize the Hohmann transfer orbit, which is the most fuel-efficient path to travel between these two orbiting celestial bodies. Even with this efficient path, the one-way trip takes between 6 to 7 months of drifting through deep space darkness. For the crew, this means half a year confined in a metal can, traveling faster than a bullet yet feeling motionless. To put it in perspective, a trip to the moon takes 3 days, while Mars requires a journey 60 times longer. To conquer this distance, SpaceX has developed Starship, the largest and most powerful flying object ever built by human hands. This beast is powered by Raptor engines, designed to burn liquid methane and oxygen, fuels that can be manufactured on Mars. The system consists of the Super Heavy booster for leaving Earth and the Starship upper stage for the long journey ahead. However, getting to orbit is only the first step. The ship arrives there with nearly empty fuel tanks after the launch. A single rocket launch cannot carry enough propellant to lift off from Earth and also propel a heavy ship to Mars. This introduces the critical concept of orbital refueling, a game-changing technology that makes the journey to the Red Planet physically possible. Specialized tanker ships must be launched in rapid succession to meet the passenger ship and transfer propellant while in orbit. Docking two massive vehicles moving at 27,000 kilometers per hour requires sensors and thrusters working in perfect automated harmony. Transferring cryogenic fuel in weightlessness is technically difficult, requiring settling thrusters to push the liquid towards the pumps for transfer. Once the tanks are topped off, the Starship is finally ready to fire its engines again and break free from Earth. This trans-Mars injection burn accelerates the ship out of Earth's gravity well, beginning the long and silent coast through the void. As Earth shrinks behind them, the crew faces the reality of leaving everything they have ever known for a new world. Life on board shifts to a routine of maintenance and exercise, fighting the muscle atrophy that comes with living in weightlessness. But outside the hull, a silent killer awaits. Cosmic radiation is much more intense in deep space than near Earth. On Earth, we are protected by a magnetic field, but out here, high-energy particles strip away at the very cells of the body. Studies suggest that long-term exposure can reduce the density of synapses in the brain, potentially affecting cognitive functions and memory. To mitigate this, the ship's design may use water tanks or fuel reserves as a physical shield around the sleeping quarters. Solar flares pose an acute risk, requiring the crew to retreat to a heavily shielded storm shelter deep inside the vessel. These moments of confinement within confinement will test the psychological resilience of every person on board the interplanetary transport vehicle. Communication with Earth becomes a test of patience, with signal delays ranging from 4 to 24 minutes each way. Real-time conversation is impossible. They are truly alone, relying on their training and each other to solve any sudden emergencies. Finally, after months of travel, the red planet looms large, transforming from a point of light into a massive world. Now begins the most dangerous phase of the mission, slowing down from interplanetary speeds to a gentle landing on the surface. The ship hits the atmosphere at 7.5 kilometers per second, relying on its heat shield to survive the inferno. Mars has a cruel atmosphere. It is thick enough to burn you up, but too thin to slow you down effectively. Traditional parachutes are useless for a ship of this mass. The air is simply not dense enough to inflate them properly. Instead, Starship uses supersonic retropulsion, firing its engines against the supersonic airflow to act as a powered brake for descent. It performs a belly flop maneuver, falling horizontally like a skydiver to maximize drag before swinging vertical for the final landing. In the final seconds, the engines reignite to flip the ship upright and slow it down for a soft, precise touchdown. They have arrived. But landing is only the beginning of the struggle. Now they must survive in a hostile, barren wasteland. Stepping onto the surface, the crew faces a world with no breathable air, freezing temperatures, and soil that is toxic. The priority is ISRU, In-situ resource utilization, which means living off the land rather than bringing everything from Earth. Technology like MOXIE works like a mechanical tree, inhaling the carbon dioxide atmosphere and splitting it to produce pure oxygen. This oxygen is not just for breathing. It is the crucial oxidizer needed to refuel the Starship for the return trip. They must also mine water ice from the soil, electrolyzing it to create hydrogen for fuel and oxygen for life support. Power is life. Acres of solar panels or nuclear reactors must be deployed immediately to keep the life support systems running. Global dust storms can last for weeks, blocking sunlight and coating solar panels, threatening the colony's fragile energy supply grid. Maintenance becomes a daily battle against the pervasive dust, which is electrostatic and clings to suits, machinery, and viewports. Psychologically, the crew must build a new society, relying on each other for emotional support in an environment that wants to kill them. The isolation is profound. They are the furthest any human has ever been, pioneers at the edge of known existence. Yet the vision drives them forward, to transform this outpost into a self-sustaining city, a second home for humanity. The return journey is possible only if they have successfully manufactured their fuel, completing the cycle of interplanetary transportation. Returning home proves that we can become a multi-planetary species, safeguarding the light of consciousness against any future catastrophe. From the launch pad in Texas to the dusty plains of Mars, this is the most ambitious engineering project in history. Thank you for watching Dark Sky Dive. Subscribe for more deep space analysis as we continue our journey to the stars. The universe is vast, and our exploration has only just begun. Stay curious, and we will see you in the next video. Let's delve deeper into the specific mechanics of the Hohmann transfer, the mathematical elegance that guides our path through the stars. To leave Earth, the ship must achieve escape velocity, but to reach Mars, it needs a precise hyperbolic excess velocity. If the launch angle is off by even a fraction of a degree, the spacecraft could miss the planet by millions of miles. Mission Control constantly monitors the trajectory, ready to upload correction maneuvers to the ship's computer to ensure a perfect arrival. Mid-course corrections are routine but critical, using small bursts of fuel to refine the path as the ship travels deeper. The ship navigates using star trackers, cameras that look at the constellations to determine exactly where the vessel is located. Unlike the tiny capsules of the Apollo era, Starship offers a cavernous interior volume, essential for the mental health of the crew. The design includes private cabins, common areas, and even viewing decks, making the long voyage more tolerable for the human mind. Life support systems must operate in a closed loop, recycling every drop of water and every breath of air for months. Fresh food will be grown in hydroponic gardens, providing nutrition and a psychological connection to nature amidst the sterile metal environment. Without gravity, Bones lose density and muscles weaken, so daily intense exercise is a mandatory prescription for every crew member. Some mission concepts even propose spinning the ship to create artificial gravity, though this adds significant engineering complexity to the vehicle. The psychological effect of the break-off phenomenon occurs when Earth becomes invisible, detaching the crew from their history and humanity. Entertainment and structured leisure time are vital to prevent boredom and conflict among the crew during the long, monotonous transit. Medical emergencies must be handled on board with automated surgical systems and telemedicine, as returning to Earth is not an option. Redundancy is key. Every critical system has a backup, and every backup has a backup, ensuring survival despite mechanical failures. While the asteroid belt is not a dense field like in movies, micrometeoroids pose a constant threat of puncturing the hull. Future materials may include self-healing polymers that can automatically seal small punctures, preserving the precious atmosphere inside the spacecraft. As they approach Mars, the crew begins to prepare for the transition from deep space travel to planetary operations. Briefings become frequent as the team reviews the landing coordinates, weather data, and system status for the final descent. Spacesuits are checked and rechecked, as these will be their only protection once they step out onto the alien surface. The ship enters the gravitational sphere of influence of Mars, accelerating as the planet pulls it in towards the atmosphere. The horizon of Mars curves below them, a dusty orange arc that marks the boundary between the vacuum and the ground. Sensors scream as the external temperature spikes to thousands of degrees, plasma licking at the tiles of the heat shield. Inside, the vibration is intense. The ship is essentially riding a controlled explosion of friction through the thin Martian air. The flight computer makes thousands of micro-adjustments to the flaps every second, keeping the ship stable during the chaotic descent. Speed bleeds off rapidly, dropping from hypersonic velocities down to subsonic speeds, preparing the vessel for the final landing burn. The roar of the engines returns, a comforting sound that means the plumbing has worked and the fuel is flowing correctly. Thrust displaces tons of regolith, creating a temporary crater as the massive feet of the Starship seek a stable purchase. Sensors confirm the ship is vertical and stable. The suspension has absorbed the impact, and the crew is safe on Mars. Cheers erupt in mission control on Earth, though the crew hears them 20 minutes later due to the speed of light lag. There is no time to rest. Preparations for the first extravehicular activity begin immediately to assess the ship's exterior condition. The Mars suits are different from orbital suits. They are designed for walking, bending, and withstanding the abrasive dust of the surface. As the airlock cycles, the hiss of escaping gas marks the transition from the Earth-like environment inside to the alien world outside. Descending the ladder, the gravity feels strange. 38% of Earth's pull, making the heavy suit feel surprisingly light and manageable. They plant sensors and beacons, establishing the first coordinates of a base that will hopefully grow into a thriving colony. The landscape is beautiful in its desolation. A vast expanse of red oxidation, volcanic rock, and a pinkish-hued sky above. Scouting rovers are deployed to find flat ground for the habitat modules and to locate the best deposits of subsurface ice. Energy is the first priority. Roll-out solar arrays are unfurled to catch the weak sunlight and begin charging the colony's batteries. Cables are run back to the Starship, which acts as the initial command center and dormitory until separate habitats are constructed. Autonomous 3D printing robots begin using Martian soil to sinter protective shells over the inflatable habitats to block radiation. Biologists begin experiments with Martian soil, washing out the toxic perchlorates to see if it can support terrestrial plant life. Geologists hunt for sedimentary rocks, looking for microscopic fossils that would prove life once existed on this now dead world. Night falls quickly, and temperatures plummet to minus 100 degrees Celsius, testing the thermal insulation of every piece of equipment. Above, the two potato-shaped moons, Phobos and Deimos, race across the sky, a constant reminder that this is an alien world. Sleep comes hard in the low gravity and strange environment, but rest is essential for the grueling work schedule of the next day. Morning brings a check of the air filtration systems. Dust is the enemy, and keeping the habitat clean is a matter of survival. Suits must be cleaned meticulously. Martian dust is sharp and abrasive, capable of wearing down seals and joints over time. The drilling rig is fired up, boring deep into the crust to reach the glaciers of water ice hidden beneath the regolith. Extracting water is a triumph. It means drinking water, oxygen for breathing, and hydrogen for the rocket fuel are now available. The Sabatier reaction is started, combining hydrogen from water with carbon dioxide from the air to produce methane fuel and water. Slowly, the tanks of the Starship begin to fill, a process that will take many months to generate enough for the return. Dust devils swirl across the plains, captured on camera, adding to the dynamic and active nature of the Martian weather system. Safety drills are constant. A hull breach or fire is fatal, so the crew practices their response until it becomes muscle memory. Psychologists on Earth monitor the crew's voice stress and facial expressions, looking for signs of depression or interpersonal conflict developing. Messages from home are the highlight of the day, digital lifelines that connect the explorers to the humanity they left behind. Through a telescope, Earth is just a bright blue star, a humbling sight that emphasizes the fragility of our existence. As the mission progresses, the base expands, with new modules connected to create laboratories, workshops, and larger living spaces. Pressurized rovers allow for longer expeditions, letting scientists explore geological features hundreds of kilometers away from the main landing site. Lava tubes are of particular interest. These natural caves could provide massive, radiation-shielded spaces for future underground cities. Ice cores drilled from the poles could reveal the history of Mars's climate, telling us when and why the planet died. Machinery breaks, and without a hardware store, the crew must become masters of improvisation, repairing complex systems with limited tools. 3D printers run constantly, manufacturing spare parts and tools on demand, reducing the need to carry tons of spares from Earth. The Martian day, or sol, is 39 minutes longer than Earth's, slowly desynchronizing the crew's sleep cycle from mission control. Celebrating a birthday on Mars is a surreal experience, a moment of human joy amidst the high-stakes environment of survival. As the next alignment window approaches, thoughts turn to the return trip. The ship must be ready to fly again. Starship undergoes a comprehensive checkout. Engines, heat shield tiles, and avionics must be perfect for the ascent back to orbit. The fuel tanks are finally full, filled with methane and oxygen harvested from the very atmosphere and soil of Mars. The base is placed into hibernation mode, systems powered down or set to autonomous monitoring until the next crew arrives. Saying goodbye to the red dust is bittersweet. They have survived the impossible, but the pull of home is strong. Engines ignite, and the ship rises on a pillar of fire, fighting the gravity of Mars to return to the black sky. Looking down, the habitat looks tiny and fragile, a testament to the courage of those who dared to live there. Once in orbit, the trans-Earth injection burn is calculated. They are riding the Hohmann transfer slide back to the blue planet. The return trip is another long wait, but the mood is different. They are heroes, returning with knowledge that will change history. Scientists on board spend the return trip analyzing the samples and data, preparing the discoveries that will be shared with the world. Their bodies have adapted to Mars' gravity, so the return to Earth's stronger pull will be physically punishing and require rehabilitation. Seeing Earth grow in the window brings tears. The vibrant blue and white contrast sharply with the red monotony of Mars. Re-entry at Earth is faster and hotter than at Mars, testing the heat shield to its absolute limit one last time. The ship maneuvers for a precise landing at the spaceport, the sonic booms announcing the return of the interplanetary travelers. Ground crews rush to the ship, the hatch opens, and the smell of Earth air rushes in, sweet and thick with oxygen. They are carried out, too weak to walk in Earth gravity, but their spirits are soaring with the magnitude of their achievement. The world watches in awe. Humanity has officially become a two-planet species, and the door to the solar system is open. This mission proves that the barriers of distance, radiation, and logistics can be overcome with ingenuity, courage, and relentless determination. A new generation looks up at the red dot in the sky not with fear, but with the knowledge that people are there. This is just the first of many. Fleets of starships will eventually ply the void, carrying thousands of colonists to build cities. In the distant future, We may even terraform Mars, thickening its atmosphere and warming it to create a second green Earth. We have looked at the lethal radiation, the suffocating atmosphere, and the crushing isolation, and we have found solutions for them all. Private companies and national agencies working together have accelerated this timeline, turning science fiction into science fact within our lifetimes. Full reusability of the Starship system is the economic key, bringing the cost of a ticket to Mars down to affordable levels. The ultimate goal is a self-sustaining city of 1 million people, a backup drive for civilization in case Earth faces catastrophe. We must also navigate the legal and ethical questions. Who owns Mars? What laws will govern the first extraterrestrial societies? Over generations, humans born on Mars will evolve, becoming taller and lighter, distinct from their Terran cousins due to low gravity. A new culture will emerge, separated by millions of miles but connected by a shared history and the digital flow of information. Mars is not the end. It is the stepping stone to the outer solar system, to the moons of Jupiter and Saturn. Exploration is encoded in our DNA. We are wanderers by nature, and the stars are the next great ocean to cross. Today we have covered the orbital mechanics, the vehicle architecture, the landing physics, and the human factors of the Mars mission. If you found this deep dive fascinating, please hit the like button to help this video reach other space enthusiasts worldwide. Would you volunteer for a one-way trip to Mars to build a new world? Let us know your thoughts in the comments. In our next video, we might explore the floating cities of Venus or the methane lakes of Titan. So stay tuned. The cosmos is full of wonders waiting to be discovered, and technology is finally catching up to our wildest imaginations. As we gaze up at the night sky, remember that the red planet is no longer out of reach. It is waiting. Let's take a moment to appreciate the Raptor engine's full-flow staged combustion cycle, a marvel of efficiency that squeezes every ounce of power. Methane burns cleaner than kerosene, preventing soot buildup in the engines, which is essential for a reusable rocket that flies many times. The switch to stainless steel was counterintuitive, but brilliant, providing strength at both cryogenic temperatures and the searing heat of re-entry. Thousands of hexagonal heat shield tiles protect the windward side, each one unique and critical to the survival of the ship. On Earth, the Super Heavy booster is caught by the Mechazilla tower arms, removing the need for heavy landing legs. On Mars, however, there is no tower yet, so the first ships must rely on landing legs and unprepared, uneven ground. If a leg lands on a rock or a soft patch of sand, the ship could tip over, stranding the crew forever. Engineers are developing self-leveling legs that can adjust to the terrain instantly upon contact, ensuring the ship remains perfectly vertical. Dust ingestion into the engines during landing is another concern. The high-speed exhaust can kick up debris that damages the nozzles. Future missions will land on prepared pads built by robots, eliminating the dust risk and providing a stable foundation for operations. Beyond solar, NASA's Kilopower project offers compact nuclear reactors that could provide reliable power through the long, dark Martian dust storms. Protein sources will likely come from cricket farms or spirulina algae, which are efficient to grow and require minimal resources. Lab-grown meat could also provide a taste of home without the massive inefficiency of raising livestock on a space station. Nothing is wasted. Organic waste is composted to create soil, closing the loop of the biological life support system completely. Conflict resolution training is vital. In a small group under high stress, minor annoyances can escalate into dangerous, mission-threatening arguments. The command structure must be clear but flexible, allowing for democratic input while maintaining discipline during critical emergency situations. The Outer Space Treaty prohibits claiming sovereignty, but it is vague on private resource extraction, creating a legal gray area. Ideally, Mars will be an international zone like Antarctica, dedicated to science and peace, shared by all the nations of Earth. Training the next generation of astronauts begins now, requiring skills in engineering, biology, geology, and extreme survival psychology. Analog missions in deserts and the Arctic help researchers understand the physical and mental challenges before we send anyone for real. Artificial intelligence will play a massive role, managing systems, predicting failures, and acting as a companion to the isolated crew. Robotic dogs and humanoid assistants will perform the most dangerous tasks, sparing humans from unnecessary exposure to radiation and accidents. If we find life, even just bacteria, it changes everything, proving that life is not unique to Earth but universal. We must be careful not to contaminate Mars with Earth bacteria, which could kill native life or confuse our scientific search. Certain areas with potential liquid water may be declared off-limits to humans to preserve them for robotic study and protection. One day, Mars might be a tourist destination, with hotels overlooking the Valles Marineris Canyon and hiking trails on Olympus Mons. Low-gravity sports will be invented. Imagine jumping 3 times higher or hitting a golf ball for kilometers across the dunes. Artists will flock to the Red Planet, inspired by the alien landscapes to create new forms of music, painting, and literature. Genetic engineering might eventually be used to help humans adapt to higher radiation and lower oxygen levels, creating a new subspecies. The relationship between Earth and Mars will define the politics of the future, potentially leading to trade, independence, or even conflict. But it all starts with the Starship. Without this vehicle's capacity and reusability, all these dreams remain strictly in science fiction. And without orbital refueling, Starship is just a big hopper. The tanker technology is the linchpin of the entire architecture. Without ISRU, it is a one-way trip. The ability to make fuel on Mars is what allows us to come home. And despite all the technology, the human spirit remains the most fragile yet resilient component of the entire mission architecture. This is a global endeavor. It represents the pinnacle of what we can achieve when we work together towards a goal. We do this not because it is easy, but because it is hard, and because it pushes us to be better. The rocket standing on the pad is a modern monument, a totem of our desire to understand the universe around us. We owe a debt of gratitude to the thousands of brilliant minds working tirelessly behind the scenes to make this happen. To the young viewers, study hard in science and engineering, for you are the generation that will walk on these red sands. The first footprint on Mars will be as significant as the first footprint on the Moon, marking a new era. Thank you for taking this journey with Dark Sky Dive. We hope this deep analysis has sparked your imagination and curiosity. Check out our other videos on black holes and quantum physics to continue exploring the mysteries of our incredible universe. This video was researched and produced with care to bring you the most accurate and cinematic representation of the Mars mission. Music and visuals are designed to transport you, if only for a moment, away from Earth and into the cosmos. Thank you for watching Dark Sky Dive. Subscribe for more deep space analysis as we continue our journey to the stars.